mention one other thing about this circle. I said that this circle has equation x squared plus y squared equal to 1, and a typical point on the circle is cosine theta comma sine theta, where theta is the angle underneath the radius. So that tells us, if we just substitute in for x, substitute in cosine theta, and for y, substitute in sine theta. So that tells us that cos squared theta plus sine squared theta is always equal to 1. This is a basic trigonometric identity. Usually it's written in the reverse order: sine squared theta plus cos squared theta is equal to 1. Let's try a specific example. Let's suppose that theta, just to verify that it works in one specific example, let's suppose theta is equal to 30 degrees. Alright, so cos 30, from our triangle it's square root 3 over 2. And from our triangle, sine 30 is 1/2. Alright, so substituting in, we're going to verify that square root 3 over 2 squared plus 1/2 squared should give us 1. Alright, so this gives us 3/4 if we square it, plus 1/4. And that is equal to 1. Alright, so the identity works in this specific case, and it works for all values, cos theta, sine theta. Alright, we'll be looking at trig identities a little bit later on on the sheet. Trig identities. There are many trig identities. Alright, so let's go on. Let's look at the sheet a little bit more. Alright, here we go. We're at these basic identities. Okay, that's what we're up to. So let's look at those. Okay, so we already saw sine squared theta plus cosine squared theta is equal to 1. Here's another way of seeing that. Just based on the triangle, you can see that. If we draw a triangle containing our angle theta, and if we make, if we specify that the hypotenuse of the triangle is equal to 1, okay, and let's say this side is, let's call this side y and this side x, then just like we did in the unit circle, sine theta is y over 1, so sine theta is y. And cosine theta is x over 1. So in this picture, cosine theta is x. And then we have the Pythagorean theorem that tells us that x squared plus y squared is equal to 1. Alright, or cosine squared plus sine squared is equal to 1. So that's another way of verifying this identity, using just the Pythagorean theorem. So either we use the Pythagorean theorem or the equation of the circle to see that identity. Now let's look at these two identities. All right, let me get a blank page here. Okay, so we believe the identity. This one we believe. Alright, let's divide by sine squared theta. Divide both sides, and we'll get another identity. And these identities are useful. You use them a lot in calculus and other places as well. Okay, so here we have 1 plus. Now what's cosine over sine? Actually, I really should start with with these identities. Alright, for now, let me just show you that cotangent theta is cosine over sine. Okay, I'll explain those identities in a minute. But anyway, that division gives us cotangent squared theta here. And what is 1 over sine theta? Well, let's go back. Remember the other trig functions? 1 over sine theta is cosecant theta. Alright, so we have that one there. So that gives us the second line, this one, this identity. And if we divide both sides now by cosine squared theta instead, both sides of this identity, okay, let's just look at that. This time we're dividing by cosine squared theta. So here we have sine over cosine. Well, look at this, that's tangent. I'll explain why that's tangent in a minute. Just believe that for a second, please. Okay, tan squared theta plus 1 is equal to, and 1 over cosine theta, you have to just remember these. 1 over cosine theta is secant theta. So over here we have secant squared theta. Alright, so we showed some of the basic identities. This one, and this one. Now let's go to tangent theta, sine theta over cosine. That's pretty easy, really, to see. That's pretty basic. If you just, let's go to the triangle. So this is what we want to show. We want to show that tangent theta is sine theta over cosine theta. You get that from the basic triangle. This is opposite, hypotenuse, adjacent. Alright, so tangent theta is opposite over adjacent. And if we just divide top and bottom by the hypotenuse, we get opposite over hypotenuse, adjacent over hypotenuse, and what is that? That's sine over cosine. So tangent theta is equal to sine theta over cosine theta, another basic identity. And since cotangent is 1 over tangent is the reciprocal, cotangent theta is cosine theta over sine theta. Alright, so those are those identities. And then we have these identities. Alright, these are called the sum and difference angle identities. And I'm not going to show you why these work. It's a big proof. Alright, but let's just use them in an example. Okay, let me get a new layer over here. Alright, let's look at this one, sine A plus B, and you just have to remember, I assume that this is pretty basic, so I assume that your teacher covered this. You just have to remember these. Sine A plus B is sine A cosine B plus cos A sine B. So let me just show you a typical example. Let's say you're asked to find the sine of, let me give you an angle, an angle that works here. Okay, of 75 degrees. 75 degrees is not one of our special angles, but what you have to do here is you have to realize that 75, one second, you have to realize that 75 is equal to 30 plus 45, the sum of two special angles. Alright, and then expand using this formula. So we have sine 30 cos 45 plus cos 30 sine 45. And these values you know from the triangle. So that would be 1/2 root 2 over 2, or 1 over root 2. Cosine 30, that's root 3 over 2. And this is root 2 over 2. And you could just simplify that, but let's see, let me just simplify that a little bit. That's root 2 over 4 plus root 6 over 4. So we could write that. We could write that underneath one denominator. I like that. So that's how we use these formulas. All right, another value we can find sine and cosine of 15 degrees. Let's say cos 15, so that's 45 minus 30. And other combinations as well. So you would use this formula here, this one, to get cos 15. Okay, so those are some of the basic identities. Alright, now we have to talk about radian measure. Radians are another way of measuring angles, alright, or rather than degrees. So let's talk about that for a minute. You know what, I'm going to end this one, and we'll do that in the next video. We'll start talking about radian measure. Okay, Ellie, bye for now.